Hey guys, so you've probably heard of Voyager 1 and 2, the two identical spacecrafts launched back in the 1970s. The mission was actually pretty simple at first: explore Jupiter and Saturn. And they did their job. They took the photos, they collected the measurements, but because there's no friction in space, there's nothing to slow them down, so they just kept going. They're still moving to this day. In 2012, Voyager 1 officially left the solar system, and then Voyager 2 did the same thing in 2018. And in doing that, they crossed something called the heliosphere. The sun is constantly sending out charged particles in all directions all the time, and that creates this invisible bubble that surrounds the entire solar system. That bubble is the heliosphere. Now, that bubble doesn't last forever. Where the heliosphere ends and the rest of the galaxy begins is called the heliopause. You can think of the heliopause as the outer skin of the solar system, the very edge of what we consider part of it versus not part of it anymore. When Voyager 1 and 2 crossed that edge, they crossed that skin, their instruments showed something really interesting. First off, the sun's particles basically stopped almost instantly, and at the same time, radiation from deep space spiked right away. What scientists expected was a slower transition, a gradual shift from our solar particles to the galaxy's particles, but instead it happened abruptly, in less than a day's worth of measurements. At that same location, temperatures were insanely hot, somewhere between 30,000 and 50,000 degrees Kelvin, which is actually much hotter than the surface of the sun. But temperature isn't about how many particles there are, it's about how fast they're moving. And because they're so far from the sun, there are very few particles out there. So they barely collided with the spacecraft, meaning there was no real heat transfer and no damage. Still, the fact that it was that hot is wild. Another big surprise out there was the magnetic field. We have the sun's magnetic field, and the galaxy has its own much larger magnetic field. What scientists expected was that once you crossed the heliopause, the magnetic field direction would shift dramatically. But instead, they found a strong alignment between the sun's magnetic field and the galaxy's. That raises some big questions. Is there a deeper connection between the sun's magnetic field and the galaxy as a whole? Is there something going on that we haven't discovered yet? That's still an open area of research, and honestly, if there's some invisible connection we haven't figured out, I think that's fascinating. All of this really shows just how effective our protective bubble is. Our galaxy is full of high energy particles from exploding stars, and that radiation is constantly spreading. It's harmful to us, and it's harmful to our electronics. The heliosphere acts like a shield, blocking most of that radiation before it ever reaches Earth. The fact that the particle composition changed so abruptly at the heliopause really shows how strong that boundary is. It's a literal line between safety and exposure. It also raises some bigger questions. Our planets orbit the sun, but the sun itself is orbiting the center of the Milky Way. That means over time, we're moving through different regions of the galaxy. Some areas might be denser, some might have more radiation. We don't really know. So could we ever move into a region where more charged particles are coming our way? Could our protective shield ever be compromised? Voyager's discoveries help us start asking those questions, and honestly, that alone is a win. Because curiosity is always a win. Being in a position where you want to understand more, where you want to ask better questions, that's how science moves forward. So the big takeaway here is this: our solar system doesn't just fade gradually into empty space. It has a real defined edge, the heliopause, where the sun's influence ends and the galaxy's begins. Voyager crossed that line and gave us our first direct look at what the space between stars is actually like. And it isn't empty nothingness. It's an active environment. It has particles, radiation, magnetic fields, structure, things you wouldn't expect to be happening at the edge of our solar system. And every signal Voyager sends back is information humanity has never had before, which to me is honestly mind-blowing. Thank you guys for watching.